Coming over to the directions. So the lab this week is going to be the start of chapter 5. So for this week, we're going to do kind of the last of the 1 week labs for a while. So this is going to be kind of an introduction to methods with this lab. And then next week, you're going to get your first 2 week lab, which will also be on methods. And that one will be a little bit more involved than this one. Additionally, because we are going to be doing the first 2 week lab starting next week, that means that the week after that, so I believe that's the start of April, kind of the first Wednesday of April, that will be the first day that we do something with the semester project. So we're going to be using that day to make sure that everybody has their groups formed and starts getting set up. Additionally, for the semester project, I will be putting up the directions for it on the Monday just before that lab day. So that's going to be about, what is that, about a week and a half from now, a little bit more than a week and a half from now. I'll also be sure that on this very next announcement that I make on this coming Monday, I'll go ahead and clarify all this with the exact dates for everything coming up. But I just want to go ahead and make a mention of that now, just so that everybody is aware of that. And also to make sure that for anybody that ends up watching this recording later, that they are aware of the fact that for the project days, it's probably going to be a good idea that you actually show up to those. So you should probably treat those as being semi-mandatory, less optional than the usual lab times. Okay.
Is it one project, or how many projects we're going to be doing?
For this one, it's just going to be one project. So basically, just one big program that you'll be working on. And you'll get more details about that once I put up the directions about what is about a week and a half from now. So you get additional clarification there. Okay. So going through the lab for this week, this one is going to be called Savings. I will go ahead and say now that this lab kind of builds on one of the labs from much earlier in the semester. So a pretty good chunk of this is going to be stuff that you're already familiar with. The key difference now is that you're going to be working with methods in order to complete a certain part of it. So we'll kind of cover that additional part to introduce some chapter 5 concepts. So the lab this week is going to focus on using a method that will take arguments and then return a value. The user will provide inputs to the program to perform multiple calculations related to interest building on a savings account, and then display the results of those calculations. So that part that I'm mentioning right there sounds kind of familiar. The lab that this corresponds to is actually lab 3, the one that was for compound interest. So we're going to be building on that by doing multiple calculations with different types of compound interest in this lab. So for the task, you'll go ahead and create your project called Savings and then your first and last name, or Lab 8 and your first and last name. Make sure that you include comments describing your program. And because we are going to be working with methods in this one, for this particular lab, you must also include documentation comments for the additional method that you'll be including with the proper annotation tags. So what that's referring to is the return and the param tags that are included with your documentation comment. So going through each one of the different steps for this. In step 1, you'll go ahead and include an import statement for the JOption pane class. In the main method, you'll declare a string variable that will hold the user's input from each of the input dialog boxes that you'll be using in this program. You'll also go ahead and declare 3 double variables to hold each of the numeric values necessary for the final calculations. So just like what happened back in lab 3, keep in mind that those are your principal balance, your interest rate, and then the number of years. And then finally, you want to go ahead and declare a second string variable that will hold the output to be displayed in the message dialog box at the end of the program. So altogether, you'll have 5 variables that you include there. It's 2 strings and 3 doubles. In step 2, you'll go ahead and display 3 input dialog boxes to the user. And for each of these, you'll go ahead and store the user's input into a string and then parse that input to a double to be stored into each of the 3 double variables. So when I say a string here, specifically what I'm talking about is the string that's related to the user's input from step 1 up here. And then for the 3 different double variables, that's going to be the 3 variables for your principal balance, your interest rate, and your number of years, again from step 1 up there. So it's kind of broken up into 3 parts where you're going to have your input dialog box. You'll store the user's input into a string. You'll go ahead and parse that. Then you'll display the next input dialog box, store that into that same string, and then parse that. And then finally, for the last one, go ahead and get the user's third input, store it into that string, and then parse that. So basically just the exact same kind of back and forth with getting those 3 values as you did in lab 3. The key difference now is that in that lab, you did it with the scanner class, but this time around, you're going to do it with input dialog boxes. You can also refer to the example input dialog boxes near the end of the directions to be able to see exactly what each one of those should look like. Then in step 3, so after making these 3 requests for user input, you'll include a method call to a separate method, and that separate method is going to be called calc interests. So it's just short for calculate interests. The following subparts will describe the parameters and return type for this method. So it's going to be these subparts A and B that I've included here. This method will accept 3 doubles for that principal balance, interest rate, and number of years. Just make sure that you're consistent with the order of the arguments in both the method call that you need in your main method, and then the parameters in the actual method definition itself. So basically what that's saying is that if you do it in this exact order of principal balance, interest rate, and number of years, just make sure that it stays in that exact order for both your method call and for the method definition. And then for B, this method will also return a string, so that gives you some idea as to what the return type should be. With the results of the calculations you will perform in that method. You want to go ahead and assign the method call to the second string variable for the output from step 1. So this last sentence that I've included here, that's referring to what you need to do in the main method when you actually call the method. You want to go ahead and make sure that that's being assigned to that second string variable that you had back in step 1. So then for steps 4 and 5, this is basically summarizing everything that you need to actually do in the calc interests method. So starting from step 4, in the calc interests method, you'll go ahead and use the following equation to calculate the final balance of a savings account after applying 3 different types of compounded interest. That's going to be monthly, quarterly, and annually. So the formula that you see here looks very similar to the formula from lab 3. The key difference is that now I've included this in variable here. And basically what that in is it's meant to describe the number of compounding periods per year. So essentially in the rest of the directions here, I just kind of summarize again what each one of these different variables in this equation actually stand for. And then the other thing I clarify is exactly what n should be for each one of the 3 different types of interest that you're going to calculate. So for monthly compounding, n is going to be 12. For quarterly compounding, n is going to be 4. And for annual compounding, n is going to be 1. So for annual compounding, when n is equal to 1, that's basically just exactly the formula that you used back in lab 3. And then you'll go ahead and store the results for each of these 3 calculations into each of 3 double variables that you include in the calc interest method itself. So then in step 5, after performing these calculations, you'll go ahead and return a formatted string stating the final balance with the 3 different compounding periods applied. So in a second, we'll go ahead and take a look at exactly what the overall formatting for that should look like. But one of the things to clarify is that the final balances must be formatted to 2 decimal places, since these are going to be monetary amounts. And then you can refer to the contents of the example message dialog box to see how the string should be formatted. And then step 6, so this is going back to the main method now. This is just the very last part of the main method. You'll go ahead and display message dialog box to the user with the output string returned from the calc interests method. Also remember to properly close the program at the end of the main method. So that last point is just clarifying once again, because you're dealing with dialog boxes, you want to make sure that your program is being closed and it doesn't hang for a couple of seconds after you're finished with everything. So then taking a look at each one of the different dialog boxes. So these first three right here are your three different input dialog boxes. So it's going to include things like what is the principal balance, what is the interest rate, and then what is the number of elapsed years. In this example, I also went ahead and entered three different sample amounts for these. So I made the principal balance $1,000, the interest rate was 3.5, and then the number of elapsed years was 5. One thing to clarify, I don't specify it here, but you'd be able to refer back to lab 3 to see this. But again, remember that when you deal with the interest rate, if you put this in as a percentage here, just make sure that you divide that by 100 before you actually use it in your final calculations. And so then once you do all that, you can see the message dialog box right here, which shows three different statements, one for each one of monthly, quarterly, and annual interest, and then the amounts that you get for each one of those three things. Okay. So then going through the criteria, the comments describing the program, including the documentation comment for the calc interests method. All of these comments are going to be worth 10 points in total. The import statement and the declarations of variables and the main method are going to be worth 6 points total. So just 1 point for each one of those different things you need to include there. The three input dialog boxes and properly parsing each of the user's inputs, those are going to be worth 6 points each, or 18 points total. The call to the calc interests method and then the assignment to that output string, both of those things combined. So altogether, that's going to be a single line of code, and that's going to be worth 5 points. The message dialog box is going to be worth 3 points. And then the last couple of parts deal with the calc interests method. So the header of the calc interests method is going to be worth 10 points. The three calculations performed in the calc interests method are going to be worth 12 points each, or 36 points total. And then the formatted string to be returned from the calc interest method is going to be worth 12 points. Okay. So that's going to cover everything for the directions. Next, I'll switch over to NetBeans to do an example of this, or like a quick demo. But before I switch over to that, does anybody have any questions about the directions so far? All right, so if there's no questions. So I've got the file for this already put together. It's going to be savings and then my first and last name. So go ahead and run this. So once it starts running, it'll give me the first input dialog box. So we'll go ahead and put in this case, I'll just go ahead and use the same numbers from the example that I have in the directions itself. So we'll put 1,000 for the principal balance, push OK. So at that point, it's going to go ahead and store that into the first of those doubles that's in the main method. Then we'll move on to the interest rate. So put 3.5, push OK. For that one, it's going to divide that by 100 since it needs to convert that to a decimal and then store that into the next of those double variables. And then finally, we'll have the number of elapsed years. So put 5. When I push OK at this point, what it's going to do is it's going to take those three values. It'll make a call to the calc interests method. We'll use those three values in those different equations to get the three different final balances. It'll then go ahead and put together the string with all of the information that we're going to see in this message dialog box in a second. It'll return that from the calc interests method. And then from there, since it's going to store that into a string, I'm just going to go ahead and use the string that it's being stored in to essentially to produce this method or this message inside of this message dialog box. Okay. So that's going to cover everything for the demo. Does anybody have any questions about the lab based on everything now? Okay, so if there's no questions, go ahead and pause here.